So this was C13. So if we have C13, Oscar stole my paper, man. Okay, on C13 we had a table. On top of this table we had a block. Connected to that block we had a string connected to a pulley, connected to a weight over here. Isn't that pretty? So the block on the table was 13.5 kilograms, and the weight over yonder here was 29.5 kilograms. And I said that the mu between this and this was 0.357. So that's happening right there. And I want to know what's the acceleration of the block. Now I love this problem because this problem like ties together everything we've learned in this unit in one problem.
Amazing.
So that's good. So of course we know that A is equal to F net over M, but do I know what my F net is here? No. So then I say, well, I got to figure out what my F net is. So I say, well, I know F net. Wait a minute, I had two different F nets. Am I going up and down or side to side? And you say, I'm doing both, man. Well, I'm looking for what's the acceleration of this, which is going side to side. So then I say, okay, that's the applied force plus or minus the friction force. And then I say, well, what's the applied force here? Well, again, the applied force is what's actually doing the pulling. What's actually doing the pulling here? Okay, it's not 29.5 kilograms because kilograms is a mass, and masses don't pull. What does pull? Weight is a force, yes. So the weight of this is what's pulling. So the applied force is going to be the weight of this mass. So the weight of this mass is going to be the applied force. So of course weight is really easy to calculate. W equals mg. So 29.5 times 9.81, and I get I can type this, we worked on it. Yes, thank you. So we get 289.4 Newton. So I'm going to stick that in here for FA. And now I got to find my friction force. And so I say to myself, okay, friction force I know a formula for, and FF is equal to mu mg, and clearly I gave you a mu of 0.357, and of course I know G is 9.81. The only question is which do I use? I've got two different here. And again, it's not hard. All you have to do is say to yourself, hey, this is friction, so which mass is frictioning? And clearly the mass on top here is doing the rubbing on the table. The one over on the side here isn't doing squat as far as friction goes, right? So you say, hey, this is the frictioning mass. So that was 13.5. So then I say 0.357 times 13.5 times 9.8. And here I get 47.3 newtons. So I'm going to stick 47.3 newtons up here. And then I have to stop and think and say, are these working together or are they working against each other? Well, this is pulling the only way weight can pull, but the little pulling means it's really pulling that way. So if it's trying to accelerate me to the right, then friction says I want to pull
the opposite direction.
Yeah, because friction's like that. So friction says, no, I'm pulling man this way, and you're saying, but the applied force is pulling this way. So it looks like they are fighting, which sounds like a subtracting. Now, could I put up this problem where it wouldn't move at all?
If it was equal.
You put like something in front of it.
If the FA and the FF were equal, then it wouldn't move unless I bumped it. Once I bumped it, it could only move at a constant speed. But if the FA is bigger than the FF, it's going to accelerate. If the FF is bigger than the FA, is it going to go to the left?
No, it'll stay.
No, it'll just stay there. So if the FF is bigger than the FA, it just stuck there. If the FA is bigger than what's left over. And what is left over here? Oop. 242.1 Newton. So that was my F net that I was missing up here. And now I just have to figure out, well, which mass is accelerating?
Both of them.
No. The one that's
Okay,
hanging.
clearly this mass, the one that's hanging, is the one that's pulling, and the one that's frictioning is the one that's frictioning, but which one is accelerating?
Both of them.
And you should say both of them, because they're kind of connected with a little string, and it's kind of hard for this one to move without this one moving, and it's hard for this one to move, and this one's not just going to stay there, it's going to fall down also. So they're both going to accelerate. They both have mass. They both have inertia that needs to be overcome. So we have to include both masses here. So how do I include both masses? I add them. So if I take 13 and a half and 29 and a half, that gives me,
That's where I messed up.
Oh, 17.9.
if you add 13 and a half and 29 and a half,
43.
I was going to say you could do that without a calculator, but never mind. No, I can't. I need a calculator at all times. So if we take our 242.1 divided by our 43, we get 5.63 meters per second. And the answer says 5.62 meters per second squared. Is that okay? Yes, because that last number is what? Uncertain, so I'm never going to count you off if you're off by that. So,
Mr. Paulson,
yes, sir.
why is it 5.63 if there's two?
If you look back to there's a 1 hiding here. If you look back at your original numbers, they were all 3.
So we look back at the original, not
Yeah.
at the formula, like at 43.
Well, because really this is 43.0 when we added them together, because the 0.5 and the 0.5, I was good at 1 past the decimal. I was just too lazy to write it.
Okay.
But actually, that was 43.0 when we added them correctly.
But it's still at the end, so it wouldn't count. So it's
Yeah, if you just wait till the end and look at your original numbers, you're in good shape.
But we still round with all the other ones.
Well, you don't want to over round in each step. That's the biggest problem you have. Is people? I tend to like if I see that everything has 3 sig figs, I tend to like to write 4 out when I'm doing everything and then wait to the end. Because if you're rounding in every single step, you tend to over round and you get off. So. But yeah, I like this one because again, we had to calculate weight, we had to calculate friction, we had to calculate net force, we had to do the F equals FA. So we ended up using everything that we learned in this week. So that's kind of fun, right? And totally manageable. We're going to dominate on this problem tomorrow, right?
Yeah.